Hey, boys and girls and parents, here is a review of the work we've been doing in data management, which just really has to do with graphing. Here's some things that the grade 4 and 5s need to know. They both need to know how to do pictographs, which are graphs that use kind of icons or pictures. Grade 5s are going to do a broken line graph. Typically, it's around temperature. And the grade 4s and the grade 5s need to be able to do a bar graph that has intervals on it. They're going to have to also interpret some circle graphs, and we'll talk a little bit about surveys and things like that as well. So I have the kids kind of make some jot notes. For example, why do we do surveys? Really to answer a question. We can easily say what's the most popular, but we might also want to talk about why. Why are dogs the most popular or something like that? And also, this is more a grade 5 issue, but if you asked grade 5 boys a question, could you apply that to a different group? Like, who could you apply it to? If you got the information about what their favorite sport was, for example, could you apply that to the kinders in our school? Could you apply that to grade 5 girls in our school? Could you apply that to adults? The basic idea is the closer that the other group is to your original group, then the more applicable it is. So for example, in this list, I'd say probably the grade 5 girls are the closest. But again, girls and boys might like different things. So you have to kind of look at the populations and try to think which two populations are similar and try to apply the information you learned from one survey to another. Here's an example of what's your favorite sport or something like that. What other related questions could you do? As long as you're asking sports question, then you're okay. Other related sports questions, what's your famous winter sport or things like that. But if you jumped over to what's your favorite cookie, those questions would probably not go together in a survey. Now, a lot of our graphing has to do with making a scale of some sort. So the steps to figuring out what scale to use are, I'm going to use this data down here, this temperature data. You first of all kind of look at what the range is. So the range, the lowest number is 1, and the highest number is 35. Really, the 35 is the most important point here. 35 is going to be the highest bar, so it has to be somewhere on the graph, and it should stretch to near the top of the graph. So typically what we do is we find the range, and we usually look at what's the biggest number. The biggest number is what we really want, the range, and find the biggest number. Let's just do it that way. And then we do some rounding to find a number that is a round number that is bigger than 35. So in this case, I could do 40 or I could do 50. Either one of those would work. If I did 40, then I'd put 40 at the top of the graph and I'd be counting by 4s all the way up. If I did 50, I'd put 50 at the graph and I'd be counting by 5s. So let me see what I mean by that. I made a boo-boo when I made this. Usually I'm going to give them a graph that only has 10 boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just pretend the graph only goes this high. So if I went with 50, then there's 10 different boxes here. So if I move the decimal over here, you're going to realize that I'm counting by 5s here. 0, 5, 10, 15, 20, 25. Yep.
Sorry, buddy.
No problem.
I
I didn't check my email yet. No.
Okay, no, it's fine. If it is, I'm gonna try and get those nets free for Friday.
Okay.
Yeah.
Yeah.
Know the guy.
Awesome. What's his? You know his name? I know his name. I forget his name now.
Sorry.
Oh, wrong guy.
Yeah.
Yeah.
Stephen Carr's there too. So.
Yeah, Stephen Carr is the guy I know.
Okay, sorry.
Okay, no problem.
Okay. Good night.
Yep. And I can keep going with this. 30, 35, 40, 45. And then my graph will be fine. So typically, whatever that number is, let's pretend the number is 182 is my biggest number, let's say. What I would do is I would round up. Let's just say I'd go up to 200. I put 200 at the top, and then I'm counting by 20. So it'd be 0, 20, 40, etc. So that's how you really do a good job of looking at the scale. Look at the biggest number, round up, and then put that at the top of the graph, and then that will ensure that A, you're hopefully counting by numbers that are easy to do, and that one of your bars is going to be up near the top. You don't want all tiny bars down here or something like that. Okay? Let's go to number 3 here. Number 3 is about interpreting pie graphs. Typically, this is a very typical pie graph where we have it divided up into quarters. So this is 1/4 or 25%. So they're all 25%. So then what we need to know is how many we're talking about altogether. In this example, there's 24 animals. So I really want to know what is 1/4 of 24. So that's really 24 divided by 4. If I took 24 and I divide it by 4, how many would be in each group? For divided by 4, a really quick way in my head is I cut something in half. So 24, I'd cut it in half to 12, and I'd cut that in half, and that would give me 6. So if you cut half in half, you'll end up with 1/4. So there's my 6. So each one of these really represents 6 actual animals. So when they're saying how many turkeys are there? Well, there's 6 out of 12. How many birds? I got to do turkeys and roosters, so that would be 12 animals altogether. Same thing over here. This time there's 36 animals. And this kind of idea is really 1/3. So 36 divided by 3. 36 divided by 3. Let's take 36 and divide it up by 30 and 6. 30 divided by 3 is 10. 6 divided by 3 is 2. So the answer would be 12. That's one way of doing it. There's lots of other ways you could do it. So those are the kind of ways you would interpret that. You need to know the total, and then you need to know, is it 1/3 or is it 1/4? A lot of times maybe I might do something like this, or you'll see something like this where you've got 1/4, and this is 1/2. If there were 50 animals, that would mean there'd be 25 here, and 12.5. That's a bad number to use. Anyways, don't worry about that one. Let's now go down to this example with intervals. With intervals, you end up, the reason we use intervals is you have a lot of data. And if you just graph those numbers individually, you're only going to get 145 and 137. So we kind of organize the data in terms of different buckets. Now, I'm making a totally separate video of a slideshow, a presentation I show the kids multiple times, and that is a separate one. So I'll post that as well. But just very quickly, when I'm looking at this, again, I'm looking at the range. 0 is my lowest number, and I think 47 is the highest number. So if I go 47, take away 0, then that really is 47. So I need to deal with 47 different numbers in my intervals. In my range is 47 different numbers. So my intervals need to kind of be large enough to hold on to those 47 numbers. Again, what I do with this is to make it easy, I just round it to 50. So I'm thinking about, well, how do I divide 50 numbers into, I usually try to get either between 5 to 10 intervals. 5 to 10 buckets that the numbers are going to fall into. I'm starting at 0, and I got to end at 47. Because I'm doing 50, just pretend I want 5 intervals, or I want 5 buckets. That means there'd be 10 numbers in each bucket. So I'm going to go from 0, and I'm going to go 10 numbers. Now, kids often want to write a 10 here. But 0 to 9, that is actually 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 10 numbers. So I'm making a T-chart. So any number that's 0 to 9 will fall in here. Then I do 10 to 19 and 20 to 29, etc., till I get to 40 and 49. And I've got 30 and 39. So now, if I have a 0, well, that would be a tally of 1 here. 32, that would be down here, and so on and so on. And that would give me my tally marks for the different intervals. So maybe I'm doing a bar graph, so 0 to 9 goes here, and maybe 10 to 19 goes here, and then I color in how high these things go. But again, just to review, with intervals, the important thing is taking the high number and subtracting the low number, and that gives you an idea of how many numbers you're working with. Then you want to divide that number by 5 or 10 to tell you how many intervals you want to get. That's usually 5 to 10 intervals is usually a good number. But I've also seen in the textbook 3 intervals or 4 intervals as well. Last page, this is solely for the grade 5s, and it has to do with mean, which is kind of like the average, and mode. Why do you use the mean and mode? We use it because sometimes we want to have one number that is the best representation of the data. There's different ways of coming up with what that number is. One way is to do the mode. Just look at what's the most popular number and do that. So the pros of that, of the mode is the most popular, or a better way of saying most common number that you might find in data. The pros is it's kind of easy to make. And if you have a lot of numbers, the mode kind of works because it's the number that came the most common. The downside is that it doesn't always take into account all the numbers. It just takes into account a small portion of numbers. So it doesn't take into account all the numbers. So for that reason, it's not always used very well. What's the mean? The mean is kind of the average. The pros is it does take in all the numbers. Every number gets to contribute. The downside to the mean sometimes, if you've got numbers that are outliers, that are far away from what everything else is, it can skew it one way or the other, but that's kind of beyond grade 5. The other con really is it's harder to do. So how do you do the mean? First of all, you add all the numbers, and then you divide by how many numbers you have. So divide by the number of numbers. So if I had 5 numbers I added together, I would divide by 5. Let's take a look at this thing here. I'm looking for the most common number in this short little data. Oh, 20. Oh, 15 as well. So in this case, the mode could be 15 and 20, but normally it's just one number. What's the mean? I'm going to add it all up. So let's say 20 and 20 is 40, and 15 and 15 is 30, and plus 10, and that gives me a total of 80. And 80, and then there's 5 numbers, so I do 80 divided by 5. Is that right? 40, 30, 20, 20 is 40, 50, yeah, 80. 80 divided by 5, sorry about that little brain freeze there for a second. 80 divided by 5 is 16. Is that right? Wow, that's a hard one. I might need a calculator for that one. Anyways, that is a review of what you need to know for the test on graphing. Good luck. Bye-bye.